Hey guys, how are you all doing today? I hope you had a good spring break. I know you didn't hear from me from a week. I know it broke your heart. It broke mine too. So I hope you had a good Easter on Sunday and everything went good. It's not normal, but got to make the best of it as you can. So today we're going to keep trucking in on the law of cosines. If you recall, we worked on the law of sines first. That was when we were given an angle and a side that corresponded with it. So in like my example here, I would have had one of the angles to go along with one of my side angles, and then I could have set something up from there. So then we moved on to the law of cosines, which is what we did last week. And the law of cosines was used when you could not find that control, when you could not find an angle and a side that matched and you couldn't move on using the law of sines. So everything we did last week, we were given two sides and an angle. If you are not familiar with that, go back and watch week 11 video again. It won't take you that much time. It'd be a good recap. This week, what we're going to do is we're going to only have side angles. So everything that we're only going to have side measures. Everything that we're going to need to be able to find here are angle measures. Sorry, I'm getting my words mixed up. So all of our problems today, we're going to have three sides. We'll be looking for all the angles. So I went ahead and wrote the law of cosines over here on the right. Remember, there were three variations set up for whatever each variable was, and remember that it's all the same formula. It's just changed around for what variables. So there's no reason to remember three of them. Just remember one of them and know the places of where they go. Also important to remember is that this picture is not drawn to scale. I told you that this is the way that I generally draw most of my triangles, just A, B, and C. It's just a normal looking triangle. It does not matter what it looks like. As you can see, it's not drawn to scale because 21.1 and 9.47 look like they're the same, but they're not. Okay, so moving on over here to my picture. I need to pick an angle that I need to solve for. I've got all my sides, so there's no reason to look into finding a side because I already have all three. So I need to find an angle. Any old angle will work. I'm just going to go with A because it seems logical. So I'm going to use the formula up there for A. Okay, I'm going to plug in all the information that I've got. Side A will be 9.47. And then I've got side B is 15.9 and 21.1. Then I've got minus 2 times B and C. So that would be 15.9 times 21.1, all times the cosine of angle A. So I'm going to start doing some multiplication here. 9.47 squared gives me 89.6809. I'm going to keep that in my calculator so I don't lose the decimals. So 89.68 or so. So just make sure you're exact with this. 15.9 squared is 252.81. I'm going to go ahead and get 21.1 squared. I'll write these out for you. We got time. So 252.81. 445.21. I'm going to go ahead and combine those. So 698.02. That's going to be a whole number. So 89.68. It's not going to be a whole number. It's going to be a regular number. Sorry, I forgot. Or sorry, I misspoke. So multiplying 2 times 15.9 times 21.1. That gives me 670.98. And that's still times the cosine of A. So I'm going to bring that down. Minus 670.98 cosine of A. So here's what I've got to look at. This is a basic two-step algebraic equation that you learned all the way back in Algebra 1. It might look something like this, like A equals 4 minus 3x. What you've got is a normal number on the left, a normal number next to it on the other side of the equal sign, and then you're subtracting a number times a variable. In this case, our variable is cosine A. We need to get cosine A by itself before we can do stuff with it. We're going to inverse it later, but we have to get it by itself. Okay, so 698.02 is a whole number that can, it's not a whole number, it's a regular number, that can leave first. It's like the 4 over here in this problem on the right. 4 would be the first thing to go. It would go over to the other side. You'd have 4 equals negative 3x. Okay, so that's what we're going to do here. We're going to take 698 and over to the other side. So it's gone. I'm going to calculate that. I'm going up and getting my decimal. Subtract 698.02. That gives me negative 608.3391. So I'm going to go 3, for right now. But when I calculate it, I'm going to use the whole decimal that's in my calculator. That's still equal to negative 670.98 cosine of A. Okay, so the next, in this little example over here on the right, the next thing to get x by itself would be divide by negative 3, obviously. And that would leave you with x, and it would be whatever that is. Okay, so let's do that. Let me scroll up just a little bit so we got some room. This is like the regular number, so it can go. Yes, they're decimals, but nobody really cares. They're not difficult decimals. So we're just going to divide them just like we know how to do. So that's going to be equal to cosine of A. I'm going to calculate it. Negative that divided by negative 670.98. That gives me 0.9. So 0.90664. There's a bunch of decimals here. I've got like 10 decimals, okay? So again, I'm going to keep it in the calculator. I'm not going to lose the rigidity on that number. But this is not what we're looking for. Nobody asked us to find cosine of A. Our goal is to find A, okay? So just like we did in the law of sines, whenever we were looking for an angle, we had to sine inverse. In the law of cosines, we'll just cosine inverse. So A will end up being equal to the cosine inverse of this number, 0.90664, okay? Remember, there's more to that. So I'm going to go up in my calculator. I'm going to do cosine inverse. I'm going to go up and get that number. It gives me 24.95. So A equals 24 where do we want to round to? This picture's actually not given in the correct way. They gave us, remember I told you the rounding in these books are weird because of the significant digits and stuff like that. This is rounded to significant digits. So we have 1 decimal and 2 decimal in the problem. So you can pick wherever you want to go. I'm going to go to 2 decimal places. So 24.95 would be 2 decimal places on this. So I'm going to put that up here in my picture for angle A, 24.95 degrees. Okay, so this is using the law of cosines for a picture when you're given side, side, side. Okay, so this is using it to figure out 3 sides. Now, moving forward, we still got to find the other 2 angles. The cool thing is we now have a control. Okay, so we've got an angle and the side opposite it, and we can use the law of sines if you really want to. Okay, I want to use the law of sines because I think it's shorter and easier than using the law of cosines. Sometimes some of you may rather just do the law of cosines again because you have to take into consideration a second triangle, but in most cases it won't happen in this. Now, that brings me to another point. Why do we not consider a second triangle for cosines? Now, if you don't remember what I'm talking about on the second triangle, go back and watch the law of sines video again, where we had a second triangle to go along with our with the rest of our picture. But we don't have to do that because in the law of cosines, we're using cosine. Okay, so I'm going to draw you a little simple unit circle over here on the right and label the quadrants. Sines match next to each other. So sines matched in 1 and 2 and sines matched in 3 and 4. But cosines match on top of each other because they are the x values. Okay, so it's irrelevant in this case because something that matches in quadrant 1 down to quadrant 4, those values are negative, and we would never have negative side angles and stuff like that. Okay, or side measures, I'm sorry. So that's the reason that we don't have to take into consideration the second case in the law of cosines. Okay, when we take a cosine inverse. Remember, that was when we did a sine inverse. So now moving forward, I'm going to use the law of sines. I'm going to set it up for A as my control over A. I'm going to set that equal to, let's just go for B, because that's logical to go for next. And I'm going to fill in the information. So I got sine of 24, I believe I wrote that wrong. Sine of 24.95. When I type that in, I'm not going to forget the rest of the decimals. I'm going to let the calculator use it. So 9.47 is equal to, I don't know B, all over side B, which is 15.9. I'm going to scroll down so I can get some space here. All right, after cross multiplying, I would get 9.47 sine of B is equal to 15.9 sine of 24.95. Okay, and divide by 9.47, and that would give me sine of B, which is equal to whatever that decimal turns out to be. Okay, I'm not interested in sine B again, so I'm going to take the sine inverse. So B would be equal to the sine inverse of, again, whatever that decimal turns out to be. I'm going to type all that into my calculator at once and let it do it for me. So the sine inverse of 15.9 times the sine of, I've got to go back up and get that decimal, all over 9.47. That gave me 45.1. I'm rounding to 2 decimal places, so I'll go 10. Okay? Degrees. Now, I know you're probably thinking that we have to take into consideration the one that matches it over on the other side. 180 minus that number would output us 134.89. 134.89 could be another one, but let's think about it. 134.89, if I add the 24.95 to it, would give me 159. And if I subtract, that leaves my third angle being only 20 degrees. For that would be angle C. Look up here at my picture. So you don't always have to go through this whole process. You can just think it through in your head. The second triangle would output me angle C being 20 degrees. Side C is the biggest side on the triangle, so it's absolutely no way that it could work. Okay, so what I did was I just took you through very quickly how to determine whether the second triangle would work on the law of sines or not. Again, if you're confused on that, go back and watch that video, and it'll explain it to you a little bit better. But in this case, the second triangle could not work. It would be far too large for that angle, and it would make the triangle not make sense. Okay, so I'm going to put 45.10 in up here for B. 45.10 degrees, and now C will be easy to find because I can take 180. I can subtract 24.95. I can subtract 45.10, and that'll give me 109.95. 109.95 degrees. That is our angle C. Okay, so let me scroll you out here so you can see all the work at once. If this confused you down here when I was talking about the second triangle, watch that video again. I know I've said that 3 times now, but watch it again and it may make more sense. Okay, let me take you one more quick recap on it. The reason was because subtracting from 180 to find, this is 45.10 is over here in quadrant 1. Okay, the other one that matches is over here. It's like 134 degrees. Okay, so if I made B 134 degrees, it doesn't leave enough for C. Okay, C's the biggest side. It has to have the biggest angle, but in this case it doesn't. Okay, so that's why it does not work. Generally, when you do a law of cosines problem, there will not be a second triangle, but it's always worth checking. Again, if you don't want to do the law of sines, after you find your control, just set up the law of cosines again, but it tends to be just a little bit more work. Okay, so if you guys have any questions, just send me a message or anything like that. I can send you a little screenshot, or I can send you a video or whatever you need to get you straightened out. Let's work on page 319. Numbers, I picked out 6 for you. So 11, 12, 15, 16, 23, 24. So all of these problems are like this, where you have 3 sides, and you're looking for all of the angles in the pictures, and should be able to follow this process as you go along. Okay, so if you have any questions, try rerunning it and watching it again. If not, let me know, and I should be able to help you through. I'll see you guys next week.